Okay, here's a second example from this topic. We are again drawing Lewis structures for molecules with one central atom and no octet-rule exceptions. So we're going to draw the Lewis structure for hydrogen sulfide. They give us the chemical formula of this molecule. And the first step is to count all the valence electrons of the atoms. Well, we've learned how to do that already. We've identified the atoms present, the kind of atoms present in this molecule is 2 hydrogen atoms and 1 sulfur atom. So if I go to the periodic table and check to see which main group they are in, hydrogen is in group 1, so it has 1 valence electron. There are 2 hydrogen atoms, so there are 2 valence electrons total, 1 valence electron from each hydrogen atom. Sulfur is in group 6A, so each sulfur atom carries 6 valence electrons, and there's only 1. So we have a total of 6 valence electrons from that 1 sulfur atom. If I add these up together, that gives me a sum of 8 valence electrons to work with. So step 1 is done. Okay. The next step is to place 1 pair of electrons in each bond. So we need to actually begin to draw our Lewis structure. And I have to ask myself, all right, so which atom goes in the middle? Well, again, we know that it's going to be typically the least electronegative atom, and it is never going to be hydrogen or fluorine. So that leaves sulfur, okay, as the central atom. And I'm going to put a hydrogen here and a hydrogen here. And if you notice, I've placed just a single bond to begin with. We have to have at least a single bond between atoms. So how many valence electrons, after we finish step 2, have we spent already? We had 8 to begin with. There are 2 here and 2 here. Remember, a single bond is just a pair of electrons. Okay? So 2 here and 2 here. We spent 4 valence electrons, and we have 4 left. Next step. Complete the octets of the atoms bonded to the central atom. Hydrogen is happy with a duet. Hydrogen atoms are complete with only 2 electrons. So he's happy. He has access to 2 valence electrons here, okay, being shared in that polar covalent bond. And this hydrogen atom is also satisfied with its duet. So our last step here is to place any additional electrons on the central atom in pairs. Well, I have 4 additional electrons, 4 electrons left. Let's place them around our central atom in pairs. So that's 2 pairs. 1 pair here and 1 pair here. So don't worry so much about how you place your pairs. You could place your pairs like that. You could place your pairs like this. We won't worry so much about that right now, but as we move to molecular geometry and you start to view these in a under a three-dimensional lens, you'll start to be able to visualize where those lone pairs actually are. But Lewis structures are 2-dimensional representations of molecules, and so we're not really too concerned about how we place them. Okay, so those are our 2 pairs. So now we have no more valence electrons to place. So let's check our work. First thing we want to do is count up all the electrons to make sure we've used all 8. 1, 2, 3, 4, 5, 6, 7, 8. Next thing we want to do is make sure all of the atoms are satisfied with either a duet or an octet. Duet, duet, sulfur atom, 1, 2, 3, 4, 5, 6, 7, 8. We have our Lewis structure.